Alright, these are the video notes for lesson 4.2. We're going to get through these fairly quickly as the examples will take quite a bit of time. Our objective today is to find the measure of interior and exterior angles of a triangle and apply theorems about the interior and exterior angles of triangles. Once again, hopefully you've already had a chance to get the vocabulary filled out using your textbook. You'll want to pause the video now and make sure that is all done before going through and watching the rest of the video. Here are a list of those vocabulary terms, and then we will also have some theorems and postulates that we look at. Start right off with our first theorem, the triangle sum theorem. This is something we've talked about several times already, but it just restates in the theorem that all the angles of a triangle add up to 180 degrees. Alright, first let's talk about what an auxiliary line is. It's a line that's added to a figure to help in a proof. You can draw any line on a diagram just because through any 2 points there is exactly one line. So you can draw any line in a diagram to help with your proof, and we would just cite that as the auxiliary line. And this auxiliary line helps us in a triangle angle sum theorem. So let's take a look at example 1a. So we've got this situation where after an accident, the positions of cars are measured by law enforcement to investigate the collision. We want to use the diagram drawn from that situation to collect, from that information collected, to find a couple different angle measures. Let's first find the measure of angle XYZ. XYZ, this angle here. Well, we have some pieces of information that are very helpful. This is a 40-degree angle here. This is a 62-degree angle. So to find XYZ, we take that sum away from the total 180, because all three of them add up to 180. So if I put in these two values into this equation and add them together by simplifying, and take away 102 then from 180, we get that the measure of angle XYZ is 78 degrees. Similarly, we can find the measure of angle YWZ. Since we know this is 40 degrees, I just found this angle measure to be 78 degrees. We can add that to this 12-degree angle. To find another way we could do this, we could find the measure of angle WXY here. I know that YXZ forms a linear pair with WXY, so I take away 62 from 180, and we get that WXY is 118 degrees. Now that I know that, I can find the measures using this smaller triangle, plugging in what we know. This is 118. We know this is 12. So to find the measure of angle YWX, we take away 118 and 12, or 130 from both sides, and we get that YWX measures 50 degrees. Alright, now let's talk about what a corollary is. It's a theorem whose proof follows directly from another theorem. Here are two corollaries to the triangle sum theorem. First, the acute angles of a right triangle are complementary, meaning they add up to the other 90 degrees. And secondly, the measure of each angle of an equiangular triangle is 60 degrees. These are things that we know to be true already. We've talked about them a lot, but they are based on these corollaries. So, in example 2, we've got several different things given. We are going to be told one of the acute angles in a right triangle. We need to find the measure of the other. Some of these, in example 2, you'll notice are variable expressions, like 2x degrees, and some of them are actual number expressions, and we will be able to find answers that are actual number expressions in those cases. But when you have a variable expression, your other angle is still going to be in terms of that variable. So we're going to let the acute angles of our triangle be angle A and angle B, and we're just going to say that one of them is 2x degrees. So to find the measure of angle B, I add that to the measure of angle A and equal that to 90 degrees and fill in what we know. 2x is what we know. The other angle is our unknown. So we're going to take away 2x from 90. So the measure of angle B is 90 minus 2x degrees. We don't know what x is, and so we must assume that that is all we can write, and that's how you'd write your answer. So for part B, we actually have a real number expression for one of the acute angles. We can set that up the same way, saying that A plus measure of angle A plus the measure of angle B equals 90. We are going to let measure of angle A be represented as 63.7. And so we take that away from 90, and the measure of angle B is 26.3 degrees. So you can see as we do these next few problems that we're just taking the given angle measure away from 90 and writing that as our answer. I'm going to let you try and do example 2C and D on your own, and then check your answers by continuing through the video. Alright, you can see that for part C, we put x in for the measure of angle A, take it away from 90, and so the measure of angle B is expressed as 90 minus x. Once again, we don't know a value for x, so this is as simple as we can write our answer. And for example 2D, you should have gotten 41 3/5. If you're using a calculator and got an answer as a decimal, that would be 41.6. However, we'd prefer to have answers written in fraction form since the given information was in fraction form. Alright, now it's time to look at some of the angle relationships within triangles. The interior is a set of all the points inside the figure. Exterior is a set of all the points outside the figure. So angles 1, 2, and 3 are in the interior. Angle 4 is considered to be in the exterior. An interior angle is formed by two sides of a triangle. An exterior angle is formed by one side of the triangle and extending an adjacent side. So we have an exterior angle here. Angle 3 is an interior angle. Angle 4 is an exterior angle. A remote interior angle is an interior angle that is not adjacent to the exterior angle. So you can see in this case, angles 1 and 2 are the remote interior angles to angle 4. The remote interior angles of 4 are angles 1 and 2. And that leads us to our next theorem, the exterior angle theorem. And that is that the measure of an exterior angle is equal to the sum of the measures of its remote interior angles. So in this case, the measure of angle 4 must add up to the sum of measures of angles 1 and 2. We could see that because angle 4 will be supplementary to angle 3. It's a linear pair with angle 3, so those must add up to 180. But the sum of 1 and 2 plus 3 is also equal to 180. So by a little substitution, we could see why angle 4 would have to be the same as the sum of 1 and 2. So let's use that in example 3a. We have triangle ABC drawn where we extend side AC through point D to get this exterior angle BCD. The remote interior angles at A and B are given with these expressions. The remote interior angles theorem states that the measure of this exterior angle must equal the sum of the measures of its remote interior angles. Sorry, the exterior angles theorem states that. So measure of A plus the measure of B equals the measure of BCD. So let's fill in what we know by substituting. 15 plus 2x plus 3 must equal 5x minus 60. We simply need to solve this equation for x and then plug it back in to find the measure of angle B. I'm going to give you a moment or two to try and solve this equation for x. Pause the video, and when you are ready to begin, click play. Okay, in solving this equation, you should have gotten x equals 26. The next step to find the measure of angle B is to plug in the value 26 for x in the expression for angle B, which is 2x plus 3. So in doing that, we get 2 times 26 plus 3. 2 times 26 is 52. 52 plus 3 is 55. Why don't you take a few moments to try example 3b on your own? Again, you're trying to find the measure of angle ACD, this exterior angle 6z minus 9. Remember, this is an exterior angle. It has remote interior angles at A and B, which is a right angle. Remember, right angles measure 90 degrees. So take a few moments, set up an equation, try and solve that equation for z. Once you've found z, plug it back in and find your answer for the measure of angle ACD. Alright, when you've gotten this far, you set up your equation like this. 6z minus 9 equals 2z plus 1 plus 90, because angle B is a right angle, that's 90 degrees. You can combine 90 and 1, they're like terms. Subtract 91 from both sides. Sorry, subtract 2z from both sides and add 9 to 91 over here. That works a little bit better. And divide by 4, z is 25. The next step is to plug z in for the measure of angle ACD, 6z minus 9. That would give you 6 times 25 minus 9, which would be 141 degrees. Okay, we have one more theorem to take a look at, and that's the third angles theorem. And it states this: if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. And here's the diagram that shows you. We have L is congruent to R, and M is congruent to S. Because of the fact that all the angles in a triangle must add up to 180, and we have congruent pairs here and here, then the measure of angle N and the measure of angle T must be the same, so they are congruent. So in example 4a, we need to find the measures of angles K and J. Now what we have here are triangles FKH and IJG that overlap. So if you think of these as two separate triangles, that's really going to help you. These are the third angles that must be congruent, because G in triangle on the right and H in the triangle on the left are congruent. F and I are also congruent, so the third pairs of angles, K and J, must be congruent as well. That means their measures are equal, so we can substitute those values. Now, there's a y squared here, so we have to be careful and remember to solve our equation using square roots. So we're going to subtract 6y from both sides, and we do get a negative, but we get to divide by that negative here. So y squared equals 20. Now I mentioned solving by using square roots, and we could do that. We could take the square root of 20 to find y, but the problem asks for the measure of angle K and J. We know they have to be congruent, so we really only need to find the measure of 1. But each expression uses just 4 times y squared. Since we know y squared is 20, we can just multiply the 20 by 4 rather than plugging in the square root of 20 and squaring it again. So we should get the measure of angle K is 80 degrees, and likewise the measure of angle J would also be 80 degrees. Why don't you take a few moments here to set up this problem the same way. You know that we have congruent angles N and S and congruent angles M and R by the third angles theorem. Angle P and angle T must be congruent as well, so 2x squared must equal 4x squared minus 32. Set that equation up, solve for x squared, and then you can plug it back in and find the measure of those angles. Okay, you should get that x squared equals 16, and again, you could take the square root of 16 if you wanted. Works out nicely to be 4, but we just need to plug in 16 for the x squared and multiply by 2. 2 times 16 is 32. If you plug it into the other one, it would also give you 32 degrees because they are congruent. Okay, this concludes our examples for lesson 2. Hopefully you've been able to get through this okay. I'm going to show you a couple more slides, and in those slides are some practice problems you could try on your own. These are not in your notes, but if you want to continue watching the video, I will show you these slides and you can try and work those problems out for a little bit of extra practice. Here you'll see 3 problems. Pause the video because it's running short on time, but try and work these out and then click play and you'll see the answers. Here are those answers. Pause the video if you need more time. And here's a 4th problem. Again, take some time, try this by pausing the video and check your answer. And this is the answer you should get for this 4th problem. If you have any more questions, please ask them in class.